Okay, good morning, everyone. Let's get started. In this session, it's basically about LKP project and LKP on ARM devices. In the beginning, I will talk a little bit about the LKP, this project, and then we'll go through the steps to run LKP on local machine and in Lava. In Lava, we'll cover the result parsing part. Finally, we will talk about the result comparison and error margins. This project actually is a young project which was initial public release is about 1 year ago. So it's in the past year it's under heavy development. By now it's much more mature, and the goal of the project is to monitor the performance of kernel, but test each commit so that it can store the data and show trends on the website. If you want to get in touch with the project, you have the email address. Also, you can subscribe to the mail list. In the very beginning, when we started to investigate this test suites on ARM devices, we to find some issues. But the hardware part, it has some limitations, like it only supports Debian file system in the very beginning, and now it can support Fedora, Debian, Ubuntu, and Arch Linux, which has been improved a lot. And we also found some package dependency issues. It caused that most of the benchmarks failed at the setup phase. Some of the features are Intel processor only. It's not available it doesn't support ARM device. So this part, we disable it, or we modify the code to add ARM architecture support. We also have some compile or setup issues. It's a lot of, to be honest, in the very beginning, only a few of the benchmarks works out of the box. About the hardware part, the test suite was developed by Intel kernel team. They are running the test suites on their Xeon enterprise class servers, which is really powerful and stable. So basically, the initial design was based on a powerful processor and fast memory architecture. Some of them are using the NUMA. Also, they ship with massive storage and the hard drives, even SSD. To solve these problems, we have Riku from the baseline team involved. We sent some patches, and most of them has been merged to the upstream project. You can see that Riku was the main contributor from Linaro. With these patches, we actually enabled LKP on ARM. By today, we almost have 24, I think it's about 24 benchmarks can run on our devices, which is really a big progress. On this slide, I'm going to cover two basic tasks. When we started to investigate a new test suite, we want to know how to run this test and how to create a new test case. Because once you know how to create a new test case, it helps you to debug the issues you maybe met during the test or debug. So this is actually a preview of the LKP tests. To write a new test case, the step one is you create a package maker script, which you place it under the package folder. This script is used to download the source code, build and install the benchmark, and finally you clean up the environment. The step two, you define the packages needed by the benchmarks, and you place this script under the root file system folder. Step three is the main test case script. You have to define the parameters and the commands. in this file, which is located under the test folder. Step 4, you create a job definition file to define the metadata and the test parameters. This file actually will be split into sub-test cases when you run the job. Finally, you need to create a result parser to pass the output of each benchmark. That should give you a general idea how to create a test case. To run a test, LKP has provided very powerful tools. Basically, it's used to split the job file and set up the test and run the test. We will go through the steps on the next slide. In this slide, it's steps to run a test on your local machine, not in Lava yet. To run that, you have to set the path, and it's not have to, but you buy to. And you set up a job. This step actually is install the packages needed and download the source code and compile and install all of that. If it failed at this step, that would be a problem in the LKP test suite. It's nothing about the kernel or nothing about the Lava. And then you split the job. When we create the job files, the YAML file, we have different parameters. It will split the job into subtests. We will see an example later. When you split the job, they provide some useful options, like you can specify the output, the kernel config, and the kernel commit. Also, on slower platforms like consumer ARM devices, they are slower. But LKP ships with a lot of default monitoring processes, like perf, time, or IO status. It's up to almost 20 processes to monitor the results, and CPU frequency and IO status, all of that. On slower process, maybe you want to disable this default processes. You can do that with the no defaults. To run a job, you can simply use the LKP run. LKP actually, this command is a wrapper. It uses the split job, set up job, and run job in this real scripts to do the job. When you run the job, also you can specify the some key and values. I will show you this later. Finally, you can use LKP results to check the result route so that you can know where they are located. With that steps, we run this in Lava. The main steps actually is the same. You can see in the bottom, you set up the job, you split the job, and then run the job finally. But we are using some very useful options which can be modified in the JSON file. When you submit the job, you can modify the parameters. The first one is the job. You can run any jobs that available in the LKP test by modify the job parameters. The second one is commit. If you want to do result comparison, you need to set the commit to the commit hash or the 40 characters. Otherwise, the comparison will fail. It cannot be recognized. One more parameter is the loops. Sometimes you probably want to know if the result produced by the benchmark are reliable, are they usable. Then you want to increase the loops and check the difference between the 2 runs or 3 runs. The last one is the monitor parameters. You can disable it by setting this value to no defaults. We run this in Lava with the definitions we have created. If you are interested, you can check it out. Once we can run this in Lava, the last task always say the most important part is result passing. Normally, this part is more complicated than you run this test. You have to, you analyze the output, you create a parser to pass the output. However, in LKP, this part actually super easy because this part of the job has been done in LKP itself. As we mentioned earlier, for each test case, you have to create a parser in the LKP test suite. It will pass the output and collect the data, save it into the JSON files. If you pay attention to the JSON files in the blue box, you can see the first one is the benchmark.json. This file was used to store all the data, basically the throughput of the benchmark to this file. The second one is stats.json. This file used to store all the data, including the monitoring tools, the proof, the time, all else states, all of them. If you run the test more than once, like multiple times, the average.json, the average.json, this file actually very useful. It will collect all the data and calculate the geography mean so that you can use the value directly. To decode the JSON files, we need to know the structure of the result root. The result root was defined in the run-local script. Most of them can be modified with the options that provided. The most important one is the commit hash. We need to modify this one with our values. Here, this is an example for a single run. If you use the test definitions and you use the default parameters, it runs the test once and send, by default, it decode the benchmark.json, which is actually the throughput, decode the key and the values, send them to the result bundle. One more thing in here is when we talk about the result passing, the first question would be what do we care and which file should be passed. To answer that question, actually, it's not easy. Different people they care about different things. By default, we decode the throughput. Of course, we can decode all of them, but too much data in the same result bundle may be not useful. So finally we decide only decode the throughput. And we have the data, it's a lot, and you don't know it's good or not, it's good or bad. So to tell are they acceptable, if it's good, we need to compare with another commit. To do that, we compress the raw data and attach it to the result bundles, which is named with the LKP minus result. The naming actually is important when we have to download this from Lava. On this slide, it's multiple runs. Sometimes you want to test if the software, even the hardware, are they reliable. You want to run the test more than once. You actually can run whatever times you want. You just increase the loops. You increase the number, and it will be run that times in Lava automatically. In result bundle, it will decode all the JSON files for this benchmark from the first run to the last run, and finally the geography mean values. From this list, it's very easy to tell are they reliable. You can see the difference between them very quickly. You don't need any compare tools here. This is for multiple runs. When the test was finished, we want to compare it with the last commit. You can do this. Normally, you can do this by manually. you need to download the results manually, and you use the LKP compare tool and specify the field that you care. Different developers maybe care about different things. Some people care about the throughput, but while others, they may care about the CPU seconds that is spent in the kernel mode or user mode. That's different. So to do that more efficiently, we created some tools to download the results automatically and to do the post-process. So the Lava download, actually from Milish, it can download you only have to give the Lava job ID. It will download the results to your local hard drive. With the data, you can use the result compare tool to compare them. You only have to give it to Lava job ID. It will compare between these two jobs. The second job is the baseline. The first job is the last commit. By default, it compares the throughput of the benchmarks. If you want to compare something else, like the time_time, this is actually the CPU seconds in kernel mode. You can use that option. Here is output example for time.system_time. This is measure how much CPU seconds this benchmark spent in the kernel mode. Compare this commit with the last commit. For this field, the lower is better. So basically, on the left column, the plus means better, and negative means bad. We actually can see some increase, and while others decreased. On this slide is a comparison of the throughput. It's two commits. The first commit is for the with mainline, kernel mainline with 4.2 RC6, and the last one is the with 4.2. Between these commits, we can see that some throughput decreased, marked with in red color. Probably that means regressions, but it's not easy to say. Most of the time, when the author of this commit, they see this kind of output, that probably means something wrong, but you want to know if it's real kernel issue or commit issues. Most of the time, they want to know, are the data, can they trust this data? Are they reliable? So normally there's a classical question, something like, show me it's not a tool issue. Yeah, so we want to talk about the error margins between runs. To evaluate the error margin, we simply run the same job on the same target device twice. It's the same software, the same hardware. With that, we compare the results between these two jobs. You can see the answer is yes and no. On the left side, we have 9 benchmarks. The deltas, actually, all of them are within 2%. So it seems like it's acceptable. Well, in others, D-bench, for example, the difference up to 60%, which is really bad. It's not acceptable. So I think if we want to start to run LKP in our regular test, we can start with the these stable ones, and we leave the unstable ones for further investigation. Yeah. And the last, the next steps, it's the things we want to do. I will leave this to Milish.
Thanks, Chase. So the next steps that as Chase mentioned, so there are some benchmarks that are stable and they produce no matter like how many times we run, they produce the results within acceptable margins, like within 2% of result variation. So we want to run them and push the results to the kernel CI. For those who were not attending the session yesterday, kernel CI is able to store the testing results already now. Maybe not present them, but I guess we want to still push the data and then work on the presentation layer later on. Then Chase prepared those pretty good comparison tools. They are not perfect because they assume that the tests were run in Lava, but on the other hand, if you don't run in Lava, you run locally, the tools are also there, you can use them. So I'm not sure whether we want to work on that or not, if there's anyone interested. So that's something we want to hear from the potential customers, whether those tools to compare results from Lava are really useful or not. As I said, the plan is to use LKP primarily on LSK. Yeah, and that's basically all we had for today, right? Any questions, comments?
Hello, thank you. I have a question about the RT kernel. So do you have any plan to run the test on RT kernel and then monitor any performance regressions for RT kernel?
Yeah, I guess we'll start from what we have at the moment. I'm not sure, do we have RT on with LSK with RT flavor? We do? Yeah, so yeah, we'll probably enable that. But as Chase mentioned, we need to do some evaluation to see if the benchmarks are stable. So if they, with the same commit, like basically the same software you run on the same hardware, does it give the same result or not? So there are benchmarks that even on the same like physical hardware give very varying results, which is not acceptable because then you will get false positives. And then we have some hardware that basically you run the same software on different physical hardware and you get very, very different results. So yeah, to answer the question, yes, we will do it, but probably we'll start from something safe and then extend the set of benchmarks. Yeah, there's Artur. Thank you.
When you run your LKP test, you make the assumption that the test is always running correctly and exiting correctly.
We're not making this assumption. We have to check first.
My question is, do you have any method or tools to make sure that the overall Linux system is not full of zombie processes that remain on the machine?
So in Lava, we're running from a clean, like we bootstrap from the metal, so there is nothing else running there.
So you are never in this situation?
So there are no like zombies or whatever like strange processes because we're starting from the clean system from reboot.
From the boot?
Yeah, so we reboot before running the benchmark. And then if the benchmark crashes, it probably doesn't produce any results, right? Yeah, so we will notice the situation when there are no results, so this means that something went wrong, benchmark crashed.
And another question is, this LKP tools collection is upstream now, or is it just...
Yeah, I guess it's maintained by Intel, isn't it? Yeah, so it is upstream, yes, on 0 day.
Thank you.
Okay, thank you. I want to know if it is convenient to compare the result from different machines.
It is.
Okay, So,
For the data policy results, we're not doing that. So basically, we might have those numbers, but we won't publish them.
okay.
We can do it in the world.
Okay, got it.
So in the comparison tool, you mentioned you could compare two results. Now, like in the parameterized job file that you showed earlier when you did 13 loops, how does the comparison tool deal with 13 different sets of test results?
The comparison tool actually doesn't care about how many runs you did. It simply go to the average.json to get geography mean. Is that it?
Okay,
Yep. Yeah. Any other questions? No, thanks for coming. That's it. Thank you.